Everyone, this is lecture number 90. Already 89 are lecturers covered to solve the supplementary problem of this book Electrolysis by M.R.Spiegel. You know this book is very important for physics as well as for mathematics. That's why we decided to solve the supplementary problem of this book. In this video, we want to solve the supplementary problem 8.87 to 8.88. If you want to watch the previous lecture, you can go to the description box. You will get the link here. So in this video, I want to discuss this problem of chapter 8, which consists tensor analysis. This is part 2 of tensor analysis. So if you want to see what the part 1, you can go to the description box. So let's start question number 8.87, which says find the covariant and contravariant components of tensor in a cylindrical coordinate system rho phi z and the spherical coordinate system r theta phi if its covariant component of rectangular coordinate are like that. Okay, so for that you need to know about the conversion from the rectangular coordinate system to polar cylindrical coordinate system as well as for spherical coordinate system. So for question A, that is the cylindrical coordinate system, you know, that is the rho phi z, and this will be related with Cartesian coordinate system, that is x equals to rho cos phi. You know very well from the cardinal coordinate system this relation, that is rho sin phi, and z equals to z, like that. So you can see here this is nothing but the uh, Cartesian coordinate, and this is the transfer coordinate system, right? This notation, you know, this notation is used in the previous lecture also. Okay, x3 equals to x3 bar. Bar is the transform coordinate system and unbar is the Cartesian coordinate system or rectangular coordinate system. So if take AJ covariant component in rectangular coordinate system rectangular coordinate system so you can see that a1 is given here, 2x minus z, a2 is given here x square y, and a3 is given here yz, right? Now let ak bar be covariant component in cylindrical coordinate system, coordinate system, clear? In the cylindrical coordinate system ak prime. So the relation between ak prime into aj will be like that, xj, this is k written in the lower side, that is covariant. The relation will be like that. You know this relation from the previous lecture. So if you want to find out a1 bar, that will be equals to x1 del x1 bar into a1 plus del x2 sorry, this will be 1 bar a2 and del x3 del x1 bar a3, clear? Now if you want to find out del because x1 is given here, x1 bar cos x2 bar, so del x1 by del x1 bar will be nothing but cos of x2 bar, clear? So this will gives you cos of x2 bar, and this is a1. A1 nothing but, I write down here a1 for that time, and this x2 by x2, this x2 will be given here x1 bar sine x2 bar. So if you derivative with respect to x2 by x1 bar, you will be get sine x2 bar. So this will gives you sine x2 bar a2, and since x3 equals to x3 bar, so del x3 by del x1 bar will gives you 0. So this become 0. So x2 is nothing but phi, a1 is 2x minus z, and x2 is phi rho phi z, and this is y x square y, this will be 0. So this becomes cos phi 2x, x is nothing but rho cos phi minus z is z plus sin phi, x is nothing but rho cos phi, and this is rho sin phi. So finally we will be get a1 is equals to 2 rho cos square phi minus z cos phi plus rho q sin square phi cos square phi. Clear? I think clear. So in this process you can also find out a2, a3 bar similarly. Okay, so a2 bar will be like that, del x1 del x2 bar a1 plus del x1 del x, no, this is 2, del x2 bar a2 plus del x3 del x3 x2 bar a3. So if you just put this value, this gives you minus rho sin phi, and a1 is 2 rho cos phi minus z plus del x2 gives you rho cos phi into this gives you rho cos phi square rho sin phi. So finally you will be get the answer like that, minus 2 rho square sin phi cos phi. I think you understand the process. If you don't understand, you must comment or you can contact with me. Just follow up this process, you will be get this answer, cos q phi sin phi. Clear? Similarly for a3 bar, this will gives you del x1 del x3 bar a1 plus del x2 del x3 bar a2 del x3 del x3 bar a3. So this gives you 0, there is no dependency, there is also 0, this gives you 1 a3. So a3 is nothing but yz rho sin phi into z. Okay, rho sin phi into z. Clear? So this is all about the cylindrical coordinate system. Now comes into the spherical coordinate system. For B, spherical coordinate system. For spherical coordinate system, you remember the relation x equals to r sin theta cos phi, y equals to r sin theta sin phi, and z equals to r cos theta. So if you note it in the tensor form, that is x1 bar sin x2 bar cos x3 bar, this will be x2 equals to x1 bar sin x2 bar sin x3 bar, and z is the x3 equals to x1 bar cos x2 bar. Clear? So in the similar process you can find a1 bar equals to del x1 bar a1 plus del x2 del x1 bar a2, and this is del x3 del x1 bar a3. So if you put this value, this is gives you sine of x2 means theta cos phi, and this is 2x minus z, that is 2r sine theta cos phi minus r sine, no, r cos theta, plus this will gives you sine theta sine phi into r sine theta cos phi whole square into r sine theta sine phi, and finally cos theta into r sine theta sine phi into r cos theta. Just put the value of a3. I think you remember a1, a2, a3. This was the a1, this is a2, and this is a3. a1 is 2x minus z, and so on. So if you just calculate, you will be get this answer 2r sine square theta cos square phi minus r sine theta cos phi plus rq sine to the power 4 theta sine square phi cos square phi plus r square sine theta cos square theta sine phi. Next for a2, if you wants to find out a2, similarly that is a2 bar equals to del x1 del x2 bar del a1 into del x2 bar a2 plus del x3 bar a3. Just find out this expression, you will be get r cos theta cos phi within bracket 2r sin theta cos phi minus r cos theta plus r cos theta sin phi and r sin theta cos phi whole square into r sin theta sin phi plus minus r sin theta into r sin theta sin phi. Just put this value, you will get the answer 2r square sin theta cos square phi minus r square theta cos phi plus r to the power 4 sin q theta cos square phi sin phi minus rq sin square theta cos theta sin phi. Just do the sum, you will get this answer. Similarly, in case of a3, this is the expression x3 bar a1 del x2 del x3 bar a2 del x3 bar a3. You will be get the answer. Just process, you will be get the answer like that. Just do the sum, you will be get the answer. Clear? Just check yourself, you will be get the answer like that. Okay, sorry, this will be 5. Okay, next we want to discuss about this question 8.87. This is the similar type question of the previous one, which is the contravariant component of a tensor regular coordinate like that. Find the covariant component in parabolic cylindrical coordinate system. Okay, in the parabolic cylindrical coordinate system. So here the contravariant component of this tensor, that is a1 is yz, a2 equals to 3 and a3 equals to 2x plus y. This is the contravariant component of tensor in this coordinate system. And in parabolic coordinate system, you know In parabolic, if you know about the cylinder in the cardinal coordinate system, this will be discussed. That is the parabolic cylindrical coordinate system. The relation is like that, that is x equals to half u square minus v square, or y equals to uv, and z equals to z. That is x1 equals to half, this will be x1 bar square minus x2 bar square, clear, and this is x2 is equals to x1 bar x2 bar, and z3, that is the x3 is equals to x3 bar. This is the relation. So for a1 bar you will be written here, that is x1 by del x1 bar into a1. You will find out the covariant component, so you need to write covariant component like that, right? So covariant component, covariant, find the covariant component in the parabolic coordinate system. So covariant component in the parabolic coordinate system, sorry, this is the right, okay, okay. So this, sorry, no, okay, x1 bar into a2 and del x3 bar a3, clear. So if you derivative with respect to x1 bar, you will be get x1 bar into a1 is nothing but yz, y is like that uv, just put here a1. Similarly, if you restrict to 1, you will be get x2 bar a2, and there is no 3 1, so a3 x1, this will be 1 x1, so this will be 0. So put the value x1 bar nothing but u, and a1 equals to yz, yz is y is uv and z is z. Similarly, x2 bar is v and a2 is 3, so you will be get the answer u square vz plus 3v. Similarly, in case of a2, so this is del x2 bar a1, so not 1, del x2 bar a2 and del x2 bar a3. Just put this value and calculate, you will be get the answer, that is a minus x2 bar a1, that is x1 bar a2 plus 0. So this will gives you minus va1 plus ua2 equals to minus vyz plus u3. So this gives you minus u v, and this is uv, this is z plus 3u, that is 3u minus uv square z. Similarly, a3 bar equals to del x1 del x3 bar a1 del x2, sorry, del x2 del x3 bar a2 del x3 bar a3. So if you calculate del x3 equals to 0, this term 0, this will gives you a3. a3 means 2y plus 2x plus y, so x is u square minus v square half into that plus y is uv, so you will get u square minus v square plus uv. This is the answer. I think clear. If there is any doubt, you must comment in the comment box. So that's it. This is all about me. This is my contact details and this is my YouTube channel details. Go to this channel, you will get the total video which already uploaded. Like this session and share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription, and press the bell icon to get the notification of upcoming video. Okay, so take care. We'll meet in the next video as soon as possible. Thank you.